All right, I think we're ready. This is going to be the start of our additive fabrication methods course. For today, we'll start out with looking over the course, the objectives, the syllabus, things like that. And then hopefully we'll have time to build our printer. It's over here. Well, it's actually behind the screen right now. You'll see it in a second. But the whole point of this course is kind of a easy way to get started with 3D printing. You don't have to have a whole lot. In fact, we'll go over a whole bunch of different add-ons, upgrades, different styles of printers, different ways to control the printer that you have, all kinds of things like that. But all you actually need is one printer. In this box, we'll open it up in a second, and one roll of filament. And you'll be able to do all the stuff that I'm going to assign in the course. In fact, a lot of the assignments are, you choose a lot of different options, and you choose the one that you want to do. If you don't actually own a printer, that's okay as long as you have access to a printer, because there are some things you actually need to go and print. It's way better if you actually own one, or you have one with you versus having to go someplace and use the printer, because some of the assignments are going to be tougher to do if you don't have like complete control over the printer. But it is possible to complete the course without actually even owning a printer. I've had people do that before. It's just a little bit tougher on scheduling things and stuff like that. But let's talk about what all the course is about. So here we are in Moodle. This introduction tab up here, it just kind of has some links to, there's a Discord channel. It already has people in there from the previous time that I taught this course. And so you might have some people who are just hanging around from the last time, and they might be able to answer some questions. I hang out in there and answer questions. You can just send me emails, and all that information is in this introduction tab in Moodle. You can go find the link to the Discord. You can find a way to set up a Zoom type meeting, office hours. I'm not really on campus too much during the summer, but if you really needed some help with your printer that we just couldn't do over Zoom or whatever, it is possible that we could set up some kind of in-person meeting to try and work on it. If you're in town, you may not be in town, I guess. So let's look at kind of the schedule of the course here. This is just going to go through some of the different topics. I have them scheduled out. There are 28, something like that, topics that we'll go through throughout the summer. It's 10 weeks long. And they're probably in the order we'll do them in, but there might be a little switching here and there. Maybe we don't get all of the printer built today or whatever, and so we have to do some of that next time or whatever. There might be a little bit of shuffling around, or maybe some new thing comes out and we insert that into one of these spots. But in general, what we'll do, the first couple of classes, maybe the first week or so, is just getting the printer up and running. Nothing fancy, just how do you get a print to come off your printer with pretty good certainty that it's going to actually work. And then we get into a little bit fancier things, maybe some of the actual G code itself. How does that work? A couple of upgrades. I have a whole box of upgrades behind me. You don't have to do any of the upgrades. The whole point of me showing off the different upgrades is in case you hear somebody say, hey, I did the whatever upgrade. They put a new motherboard in controller board in the printer, and you want to know if you want to do that too, then we'll do that at some point in the quarter, and you'll see how complicated it is. Some of them are really simple, some of them are more complicated, and see if you actually want to go do that. So all the things that I do other than like building the printer and printing on it are optional. You don't have to do any of the upgrades. I'm just showing you what they are, where I got them from, how much they cost, and how easy they are to install, and if they even make a difference. Some upgrades you put on your printer and it doesn't really make that big of a difference on most printers. So some of them do make big differences, and we'll go through a variety. If you have a particular thing that you're interested in, if you tell me early enough and I can find it, then I'll add it to the list of things to do. So we got a couple of different things here. Some of the things are talking about the printer itself. Most of the stuff that we'll do in this course is going to center around the Ender 3. So it's kind of a entry level FDM or FFF. So those are the printers that FDM is fused deposition modeling, and FFF is the same thing, but it's fused filament fabrication. So the company that kind of started a lot of the commercial version of squirting out plastic and laying it on top of each other, they kind of trademarked FDM, so you'll see FFF used a lot of times in place of what's called FDM, but I'll interchange them here and there. In fact, I see here's FDM right here on the web page. Different things. How do you print with multiple colors? How do you finish them to make them look like metal? You know, they're plastic, but how do you make them look like something else? Or do you just print with metal? There are some metal laden filaments that you can print with, and how do you do that? Different modeling techniques, like how do you create specific geometry that's good for 3D printing? We'll talk about some of that. We'll talk about other printers in here. I have one lecture on resin printing, but that's kind of interesting. If you're into really tiny details, then there are hobby level, consumer level printers that can print super high quality detailed, but it's kind of smaller. You know, there's smaller printers in general. And I do one lecture on that, and if you have questions about that, we can do more, but most of the people that are watching have the FDM, FFF style printers, the ones that squirt out plastic. They don't have the resin stuff. But I'll talk about that enough that you'll know whether you're interested in pursuing that or not. This is a little bit messier, so the resins themselves are kind of messy, and it can make a big mess and kind of can smell sometimes. But so we'll do a little talk on that. Photogrammetry, so how do you create geometry from the real world, taking pictures of it, and different things like that. So how the course works is, in this introduction tab, there's a syllabus. So here's the syllabus. And there are, again, a couple of different objectives here. Required materials, again, all you really need is access to a extrusion base, so the plastic based printer, and one roll of filament. I would recommend PLA. So that's what's in this box. Here's one roll. I've got this kind of muted orange. Actually, on the screen it looks bright orange. In person it's kind of more muted orange. But I got this orange roll of PLA. PLA is the type of filament, polylactic acid. It's a good one to start with because it prints a little bit lower temperature, which is easier for your printer to handle. And it doesn't work too badly with warping and things like that. It's kind of hard to post-process, so sanding it is tough, but you don't have to sand it a lot of times. And so you get one roll of this, and you would have, this is a kilogram of material, and it costs around $20 off of Amazon. This particular brand I haven't used before. It's a Zero 3D filament. I don't even remember where I bought it from. Yeah, I might have bought it from the same company I bought this printer. I'll see. But anyway, you get your roll of relatively decent PLA filament, and that's all you really need. You can get way more stuff, but the minimum is you need access to a printer and you need a roll of filament. Most of the other stuff is going to come in this box. We'll open it up in a second and see all the things that come in. In fact, there's probably some filament in here. It's not going to be enough to get me through the entire quarter of assignments, but it would get me started. And here how, hold on, let me go back to here. Here's how we're going to grade the course. So there are 11 things you need to do. One of them is just participate. So participation is commenting on things. Obviously, we're not all in the same room, so you can't necessarily easily ask questions. The chat is going, and I do tend to look at it on the screen, but it might be a while before I see something. It doesn't notify me other than it just shows up on the screen. So the chat is going here, but the participation is commenting on things, showing some kind of activity in the Discord or on one of the chats in here, something like that. So it's not a complicated thing. I think I just find it down here somewhere. Let's see. Yeah, here it is. Regularly participate in Discord server conversations, YouTube chat, or the course forum. There are forums on the Moodle page itself. That's what those are talking about. There's no set minimum. just some kind of interaction once a week, just so I know you're there. So that's 5%. Most of the grade, though, comes from completing prints. So there's one that I assign the exact model for you to print, and this benchy. I should have bought, usually there's one sitting around here. I don't see one right now, but it's a little boat. And all it does is it kind of gives me a way to look at the prints that come off of your printer and give you suggestions on things that you can do to improve the quality of the print. And this one, this right here, 5%, so it's half a letter grade, and you can repeat it throughout the term. You can print the really good benchy on the very first print off your printer and be done with it, or you could print 10 of them, one each week, and the last one is finally good. You know, whatever in between those two extremes, I suppose, is how this perfect print works. There are another set of calibration prints that I give you models. They're right here. These links are suggested ones. You can print other ones. Maybe you have some experience with 3D printing, or you do a little bit of background research and find different models you want to use for these. But these are 3 prints that you can make to help calibrate how well your printer is set up. One of them calibrates what's called retraction, so that it's not very stringy. Whenever your print head moves from one space to another, it doesn't leave all these spider web-like strings behind it. And so there is a retraction test you can print. Temperature tower. All of these rolls of filament, where we're at over here, all these rolls of filament print at roughly the same temperature, but a temperature tower will basically vary the temperature as the object is being printed, and you can see the best print temperature for that particular roll of filament. And sometimes you want to print a little hotter because you want the layers to stick together better. Sometimes you want to print a little cooler because you want a little bit better surface finish. And so this temperature tower will help you find a good print temperature for a specific roll of filament. And then this tolerance test helps you calibrate so that if you want a print that has interfacing parts, you can't have the parts oversized or undersized by too much. And so this tolerance test will help you calibrate that. Now, when you print these calibration prints, you don't have to print them over and over and over again until you get them perfect. For the course, I just need you to print them once and kind of see where things are at. But for your own better printing experience, you would print them again and again, tweak something and print again, you know, that sort of thing. Although the ones that I picked kind of do that in one print. They will give you an idea of a variety of settings in one print. So that's these calibration prints. Number 3 here is a contest. So this one, and I've put due dates on all of these. In the past, what I've done is I've just given all the assignments and they're due at the end of the quarter. And that works for, half the people or more. But I get a lot of feedback that they'd really like to have some staging of the assignments just so they don't get behind. So I've put things to where there's about one every week or so. Now the first one is a couple of weeks away, so you get a couple of weeks to get started, and then there's about one a week, one assignment due a week. And so that should be okay. If it ever becomes a problem, like you have to go on vacation for 2 weeks or whatever, and you just can't print for 2 weeks, that's okay. Just let me know and we will modify the due date for your assignment, and it won't be a big deal. I would not recommend waiting until August 13th and turning everything in because it is going to be a pain. So try to hit these due dates as much as possible. This one, though, number 3, I have an option here. Not an option. There's, I guess, options within this. Let's find it on here. There it is, contest. So a lot of the feedback from previous courses was that we'd like to have a contest, and see how well our prints are compared to other prints. And so what I've got here I've got 2 contests from Instructables.com. Or if you find another contest that you'd rather enter, then that's fine too. I just found these 2. You can actually win prizes on these 2. And they're relatively easy, and they can be done with 3D printing. Maybe 3D printing is not the focus of each one of them, but they can be completed with 3D printing. And so either one of these you can do, or if you find another contest, there's all sorts of contests you can enter that have something to do with 3D printing. So this one does have a due date because of these two links that I have already picked out. They end on June 21st. So if you don't complete those contests before June 21st, you'll have to come up with a different contest. So that should give plenty of time. They're not complicated, and you don't have to win the contest to get credit for it. You just have to show that you entered the contest. And then there are options 4, 5, 6, 7 are all listed as just option 1, 2, 3, and 4. So what those are is right here, option 1, 2, 3, and 4. There are all sorts of just things that you might want to print. I don't know, I didn't count them, but there's all of these from here to here. You pick one of these things that you want to do. Most of them have to do with printing, although this one doesn't. Maybe there's something you want to upgrade on your printer and you just do that for that option. But there are a lot of different options of things that I've found over the years that are interesting to do, relatively simple. Some of them are a little more complicated, so make sure you read all the options here before you go just pick one. And you pick one of these, you do it that week, and you turn it in as option 1. And then the next week, you pick another one of those same list, not the same thing, but one from the same list, and you do a different option. And you do that 4 times. And I've got them staged basically a week apart. Option 5 is a little bit different, and you need to know about it ahead of time because it takes a little more planning. So option 5, it says it's a technical brief. Right here, you have to choose one of these assignments down here. I've got 1, 2, 3, 4, 5. If you come up with something different from one of these, any of these actually, just let me know what you're thinking, and I'll probably just add it to the list. That's how I created the list in the first place, is different people wanted to do different things, and so I kept adding different stuff to it. This one, it's pretty open as it is, but if you think of another thing that would kind of fit in this same idea. So the idea for option 5 is that you spend a little more time. Maybe you're trying something experimental, or it just takes longer to do whatever it is, and you're going to write up a little 5-page technical brief about what you did. So if you think of something that fits in that category, then that's option 5. I don't remember if I weighted it more. I didn't. It's still 10%, so they're all 1 letter grade as it is. But a lot of people last time did the experimental testing, so they just devised a kind of semi-scientific test. What if I print at different layer heights? Does it make the print stronger? And so they tested that out. So they had a hypothesis and tested it. I added this one, so this milk jug design contest, or challenge, not contest, but challenge, where you take just an ordinary milk jug and you print something to make it have a new function. You know, you print a thing that screws on the top of it, and now it's a watering can, whatever. So a lot of people last time did this one, topologically optimized part. We're going to go through how to use SolidWorks and Fusion 360 to create 3D printable geometry that's optimized for weight reduction, or optimized for strength, or optimized for reduced strain, you know, something like that. And it uses software to kind of fill in the gaps of where do you actually need material to be. And so you could do that. You can use one of those packages to create something like that. Maybe you want to just do a paper. You just want to see where is 3D printing used in an industry that I'm interested in. And so how do they use that currently? And so you just want to write something, you do a little bit of research. And then there's a simulation, sort of like the topologically optimized part, but more of a motion study type thing. And then how could you use 3D printing to change this geometry to make it better? So again, that's option 5. You want to prepare for it a little ahead of time. It does have the furthest away due date of all of these. It's the last day of the quarter. And so you don't want to wait until the very end to start it, because it could take a while to do. There are 2 quizzes. They're just in Moodle. They're multiple choice quizzes, just so that we have a little bit of memory retention type things, where I ask you some questions and you tell me the answers to them. And so there's 2 of those. And then we already talked about participation. That's kind of how the course works. It's very optional on how you complete the assignments. And like I said, if none of these really fit what you were thinking for an option, then suggest a new option to me, and I'll probably more than likely add it to the list of the things that we can choose from our options. When you complete one of these, so let's go back to Moodle. You complete one of these, I've got this turn in assignments here list. The way I'm going to do those they're all forums. So you go to one of these forums and you'll be able to create an individual post with your option 1 or your calibrations or your contest entry or whatever it is. They're all here. And you'll post, most of these, the option is you post a picture of the print and then a little 1 or 2 sentence write-up of what it is, just so I know that you're turning this in as the option 1 multicolor. So you wanted to use a multicolor print. And so I know that, and you might just have a 1 sentence paragraph. Obviously the option 5 is much more verbose, but the other options, I just need a 1 or 2 sentence description of what the option is and what you did with it. Also, you'll be able to see everyone else's options that they've submitted, and you'll kind of get a sense for what other people are doing. Feel free to comment on things. Remember, you have to do a little bit to participate in the course. That's one way you could do it, is you could comment on some of these different options that other people have turned in. Okay, I don't see any questions in the chat, so let's go over here and let's show you what I bought. So this is the one I bought. I bought the Sane Smart Ender 3. This is the base, or it should be the base level. Last time I bought one of these from Sane Smart, I ordered the base level Ender 3, but they actually sent 3 Pro. So, or actually kind of this hybrid thing. It had parts from a Pro and parts from the basic one. So I don't know. I think maybe Creality might be phasing out the basic one and kind of upgrading everything to somewhere in between version 2 and Pro or whatever. I don't know. But this is what I ordered. So it was $169. It looks like right now you can get it for $155. A lot of this stuff you do have to order depending on where you're at. If you're here where I'm at, then there is one store in town where you can buy parts. The A&H Games has Ender 3s, and they have a little bit of filament. But other than that, you're going to have to order parts unless you're in a different place from here. And this is a place that I've ordered several different things from in the past. Amazon, obviously, order from them. There are other sites, some of the really cheap, you might can find this even cheaper somewhere. The only thing you have to be careful of is some of those sites don't have US-based warehouses, and it can take an unknown amount of time to get it to you. So just make sure when you're ordering it from online that you're going to get the stuff in a reasonable amount of time. Some of the places with overseas warehouses, you might wait a month before the part comes in, or the printer, or whatever it is you ordered. So just be sure that you're ordering relatively locally to get these things in a reasonable amount of time. All right, so that's what I ordered. Let's see what's actually in here. I haven't opened it yet, so let's see. Hopefully this should be the top. Yeah, open from here. So, all right. So yours should be very similar. Most all these are just the same thing on the inside, but let's see. This thing in the way. All right, so we have a warranty and some. This one actually does come with an instruction booklet. A lot of times the instructions are on a USB card type of thing. All right, I think let's get this out. So this is our control panel. Probably throughout the quarter somewhere we'll upgrade this to a touch panel. This one is just it has a knob and you turn the knob. Again, none of the upgrades are mandatory at all. Let's see what's going to be the best. Maybe this. Yeah, here we go. All right, so there are a couple of things attached to this. So this one is, and this is separate. This one is the Ender 3, just plain Ender 3. It has a thinner Y-axis guide rail. some of the version 2, I think, or maybe it's just the Pro, has a much thicker one, a 40 by 40 versus a 20 by 40, or no, 10 by 20, I guess. And they have a 20 by 20 rail here, like these. All right, so this also has this attached to it at the same time, so we got to keep that. Our control board is down in here, so let's get this out of the way. It looks like one of the knobs has fallen off. We'll come back to that. Here's going to be our feeder mechanism. So this is, the filament is going to come in actually right here. And there's a stepper motor here that is going to drive filament into our hot end. One thing you want to check for here is that this has a somehow reinforced, either this whole capstan here is metal, or there's an insert here, well, probably here too, but particularly here. The filament comes in here, and without this metal insert or without this arm being metal, it will eat a groove all the way through here, and you'll end up, it'll grab your filament at some point. So just check that you've got some kind of metal insert here, or this whole arm is metal. We'll actually upgrade or change out. It's not a terribly big upgrade, but we will change it out at some point in the quarter. But if you don't have a metal insert on the printer that you get, most of these printers work very similar. Even if you don't get the Ender 3, they have similar types of issues. And if this is just plastic where the filament is fed in, then there's a good chance that over, I don't know, a month or two, it's going to eat its way through there just by friction. Here we've got a power supply. Oh, this is an older, really old one. So it's got the bigger power supply. The newer ones come with a much thinner power supply. On your power supply, the one thing to check for is, well, yeah, look here. So they have a switch. Let's see if we can get it to where you can see it. They have a switch here. Maybe if we zoom in. Yeah, see how it says 230? I'm not plugging this into a 230 volt outlet. So I need to flip that switch over to 115, 110, whatever number it's going to say. Let's see if I can find something to flip it over with. There we go. And so it's 115 now. If you plug it in, it's set on 230, and you plug it in to your regular wall outlet, then nothing horrible will happen. But if it's the other way, like if it's set on 115 and you plug it into 230, or 220 is what it would probably be, that would be bad. But anyway, most of the time, I've never actually seen one come shipped the opposite of what it's supposed to be. But do check that, because clearly they can be that way. They can be flipped-flopped. And so assuming you're in the United States, it probably needs to be on the 115, 110 option. So there's that. And it's going to have a little plug-in here. Also on this plug-in, in the early ones, this is a mode of failure that's relatively common. In fact, I used to have a burned one. These XT60 connectors are meant to be crimped in, and there were some times where they were soldered in, and it would eventually lead to a failure here, and it would I never saw one catch fire, but they definitely have been melted here before. And so just make sure that it doesn't look like they've soldered the thing in. This one looks okay. And I haven't seen that recently either. It's been years since I've seen one that way. All right. Oh, well, I would say this is not going to give me very much filament. So they did give me some amount of filament, but only enough to just barely get started. But I do have some extra nozzles, or one extra nozzle, and then some other parts that we'll need to assemble. Got one of these. This is for removing prints from the print bed. Now this printer does have, yeah, it has a bed that's not attached to it, so I probably won't actually use this. I'll probably just flex the bed. That's also another upgrade that we'll add relatively early, because it's really simple, and it does help a lot if you print a lot. More parts. Some of the rails. And usually be careful with this. Usually they've packed your zero. Yeah, there it is. the Z-axis rod inside here, so you don't want to undo this and let that rod just slide out, and because you don't want that to be bent or dinged up in any way. Now this one, it is at least where it can't fall out, but I could just easily see being surprised by it falling out of the package there. All of our hardware. It comes with a spool holder. The problem, it's not a problem, but the issue with these spool holders is they mount on top of the printer. So it puts this big, 1 kilogram weight on top of your printer, and that can give you some unnecessary, oscillation, vibration type stuff, kind of like this inverted pendulum type thing. And so it works fine, but I usually, if I have space for it, where'd I go with it? Do something like this, where this did not come in the package. This is something I have separate, where this just lets the filament roll sit on the table, and it doesn't have this mass on top of the printer, vibrating around and kind of shaking the whole printer. But if you don't have that, that's fine. It's just, that's one thing I do. Power cable. And the Z-axis stepper with, wow, there was a random screw. Oh, not a random screw, the screw for tightening down this coupler. Definitely would have had trouble if we didn't have that. I will say it is generally good to have, all of these are metric screws on these printers, so have you a little assortment of M3, M4, and M5 screws like this, because you're not going to easily find them. They're not at Walmart, probably not at Lowe's, and so I have a little box of assorted screws, and usually there are a handful of leftovers in the bag. I think. All right, that's everything from there. All right, let's get this. There's all sorts of cables underneath here that we have to sort out. All right. Now, remember, we did have the one bed leveling screw that came off of there. It looks like it goes right here. We'll go ahead and attach that. I'm not sure if it was intentionally left off or just fell off. I will probably change this out somewhere throughout the quarter also, but not right now. So these screws, let's go ahead and talk about some of the adjustments you might make. So these, right in here, these springs are adjusted by turning these knobs, either squeezing or letting off pressure. And what that does is it changes the position of this bed. We're hoping that this bed is more or less flat. It may or may not be, but assuming that it's flat, then we can adjust its position by turning these screws. And that's called leveling the bed. It doesn't really have anything to do with level. It's closer to tramming, if you've ever done that for like a CNC machine. But the idea is that we're going to put all this structure on top of here, and the motion of this print head, so the filament's going to come out right of that nozzle right there. The motion of that print head is all parallel to this bed. And so a lot of times we have to go in and, manually level this bed. We'll actually add an instrument later on in the quarter that probes the bed, and it will adjust for any unevenness in the bed. But we're going to start out with just the base level stuff. And these springs, I generally want them as tight as I can get them, like as squeezed down as much as possible. Obviously, you could imagine a situation where these are really loose and the bed's just sitting there kind of flopping around everywhere, and that would not be good. And so I start out as much as possible with these cinched down pretty tight, so that there's not a lot of extra springiness in the spring left. So I'm going to go ahead and tighten them up as much as I can. This one's really loose. All right, so we'll start with something like that. The other thing that's different on these printers from what you might be used to is down in here. So yeah, you can see them right there. Those silver hex nuts. They look like just an ordinary hex nut, except they're not. They're eccentric. Let me see if I can find an easy, well, there's one on here. They're all attached, so there's not anything to show you, but here's one right here. These are eccentric hex nuts. So what that means is, in fact, it might be good if I could just, I don't know if I'd ever get it back together easily. They have an offset where if I turn this hex, it'll make this wheel move in and out, basically. Makes it more or less move in and out. And that's how you can take up slack in the bed. So let me show you. Mine's actually relatively set up right now. But let's assume it wasn't. Let's find our tools. I want to try and build this thing with the tools they send. They generally don't send great tools, but we'll start out with trying to use the tools they do send. So here are the tools that they've sent. An assortment of hexes, some flat wrenches, tiny little screwdriver. I guess I could use maybe something on the board with that. But let's say the larger flat wrench here. So if one of these hex nuts is not adjusted correctly, and it's not necessarily about them being tightened or loosened, it's the position they're in. So I want to change one of these positions just so we can get a feel for what would happen and how to deal with it. No, I still haven't gotten it loose. Well, it's actually getting really tight, in fact. Let's go the other way. Almost every one of these printers that I put together, they start out really floppy, but this one's actually not. Maybe the company that resells it actually goes through and adjusts stuff for me. I don't know. Huh. Well, I can't actually make it floppy, but maybe we can look at this one and see. I don't know if you'll be able to see that it's moving or not. Let's get closer. So I don't know if you can tell. There's no real point of reference, but by turning this eccentric nut, it's going to move these wheels either in or out to either grab tighter onto the rail that they're on, or back off from them. You can actually have them too tight to where they will actually get a flat spot on the wheel, and you'll feel this kind of clunking sound, or I don't know how you feel a sound, but you feel this clunkiness as you move the bed back and forth. In fact, I can feel it on here. In that case, you actually need to back off a little bit on the eccentric nut so they're not quite so tight. If it ever gets where they are actually floppy, like this whole bed is just flopping around, then you have probably need to tighten them up. And it's not necessarily that it's not righty-tighty and lefty-loosey kind of thing. It's you turn them one way and see if it's going closer in or further out, and you just have to attempt it. All right. So I'm going to call that good. I don't feel too much dragging, and the bed's not flopping around anywhere. So you may or may not ever have to adjust those. Like on this one, I don't think I would have ever had to adjust it. I might have to adjust this one so we put it on there. Let's see where we're at on time. I don't know if we're going to get this thing built today, but we'll start. I think I've covered most of the early pitfalls, and the goal will be that on Monday when we come back, I'll go ahead and finish up whatever we don't do today, and then on Monday we'll print on it. So we got a little instruction book. Just go over the different stuff that's involved here. Well, here is a potential pitfall. You've got to put these two rails on, and so the way the printers are set up, let's get it in the screen. the motor that's moving the bed back and forth, this motor will move it back and forth. It's at the back of the printer. So this is the front, this is the back. And that does give it a left and right side. And this, there's that rod coming out of there, which it did fall out. There are two different rails. They look very similar, but they are different. And so we do have to identify the left one from the right one and the top from the bottom, on the right one anyway. Actually on both of them. So I'm just unpacking them. So what you're looking for is on the right hand side, you're going to mount the power supply for this Ender 3 anyway. And again, a lot of printers are set up this way. So these two screws are going to hold that in, and you could mount it this way or you could mount it this way. And so you do have to be careful that the screws mount it where they're towards the inside. And all you do is there's threaded screws in the bottom and screw holes in the rail here, and we will screw them together with these screws. They are doing better now at labeling what's in here, so you don't have to recognize that this is an M545. They actually tell you it's an M545, and in the package they usually are telling you need the M545 screw. In the early, well, I'll get my first printer out if I remember next time, and you can see what the early days of printing was like. And the early days weren't that long ago for printing. I say that, but there's different types of printing, right? So the very first 3D printers, commercial printers, came out in the 80s, in the 1980s. And they were actually really good. They used a resin, and they still have this type of printer. They were resin-based printers, really high quality prints, and they used a laser to cure the resin selectively. So it was called selective laser apparatus. And so you might hear them called SLA printers. And so they've been around for a long time. A company, Stratasys, had a lot of the first printers like that. They're the company that I mentioned earlier that kind of trademarked the idea of, or the name FDM. And so that's why you'll see FDM and FFF also meaning the same thing. But they also had these Stratasys, I don't remember what they were called, 1200 SST type printers, and they were FDM based, but they were these big giant things. They had enclosures. They were printing ABS-like material, and they had a heated build chamber. It stayed at like 350 degrees and everything like that. And they patented among other things, they patented basically this part, the part of how you're going to extrude filament out in a controlled way. And that patent ran out. Patents only last in the US, they last for 20 years. You might get a 1 or 2 year extension if you have some extenuating circumstances, but in general, they last 20 years. And about 10 years ago, I don't remember the exact date, those patents ran out. And that's when companies like, MakerBot and some other companies started releasing. Actually, it was a homebrew type thing, open source thing at first. And people came with these variety of kits to build your own printer based on this kind of technology. And so it's only been 10, 12 years since this has been, maybe not even 12 years. I'll have to look at the exact date. But very recently that this has even been a thing. Now I'm looking at this. All right, so I see I already messed up. I put the holes on the inside, but they're at the top. So there are four different ways you can put this rail on, and I chose one of the wrong ways. All right, so let's undo that and put it the right way. Also, I haven't yet, but usually I end up getting cut on one of these pieces of rail. So these rails are all kind of very sharp. They're aluminum, extruded aluminum, and these finished or cut edges here are extremely sharp. So be careful around them because they will cut you pretty easily. All right. You definitely want to make sure that you don't do what I just did and put these things together wrong, because there are a lot of things, if you don't find it soon enough, there's a lot of undoing you have to do to like flip this rail back the right way. And it can be discouraging to have to undo all of the things that you've done to get it to a certain point. In this case, it's not that bad because we only did one thing. There we go. All right, so I had it this way. It needs to go this way, where these two holes, well, there's one of them. There's the other one, or closer to the bottom. That might be an easier way to get things lined up. Also, a kind of pain thing that you have to deal with is that you kind of assume that these rails are cut perpendicular. You know, they're perpendicular to their longitudinal axis, and that's not always 100% true. So you may have to go in and do a little bit of shimming, which I don't have any shims with me. And they don't send any in the kits. Any kit I've ever seen anyway doesn't come with any amount of shim. But it's one of the things that can happen is if you're printing, you know, you get the thing built and you're printing and it's kind of working, you know, your prints are coming out, but the first few layers are they just don't look right, and you've adjusted the height of the nozzle off the bed and everything like that. It can be that these rails, the ones that I'm putting on now, this one and this other one here, are not, and they're not going to be this far off, but they're not parallel. And what that'll do is the rail that goes across here, the Z-axis that moves up and down, it can, if these rails are not parallel, if they're off, then they will hold for a little while, and then, you know, they'll move, and then they'll hold and move. They'll kind of jam, and you'll get these layers that they didn't actually move up as far as it was supposed to, and they'll be all squished up. And so I do have a little square here. It's not so much that they're square this way, but it's that they're square, and you don't even have a good way to measure it with everything in here, but they're square to each other. But there will be a piece up here. Well, you can't see that. I'll put it down here. There'll be a piece across the top that tries to hold everything together square. All right, the left side, it has two holes. It doesn't matter if it's this way or this way, but there are two holes that need to be at the bottom. Okay, so we're gonna put it here and here. And if you have a different, you know, I said that, you know, when I sent out the first class email that I would be using the Ender 3. It's totally fine if you use a different one. The Ender 3 is just the one that I found that is easiest to get started with a low price point. There are certainly way more expensive printers. There's not many cheaper ones. There are. I did look on Amazon last night, and there were there's a $100 printer, but it didn't look very very good. You know, I haven't tried it, so I can't say for sure, but I think you would have a lot more trouble getting it tuned in and going than just spending the extra 50 or whatever it is at the time and getting something that's going to have a large community of people. One of the biggest sources of information for getting these printers, Ender 3, the ANET, the TiVo, whatever it is, they all have pretty active Facebook groups. I know that Facebook is not particularly popular these days, but it is really good for these printers for whatever reason. Reddit is okay, but they seem to have a much more active Facebook group. So go find the Facebook group for whatever printer you have. And what amongst the help that you'll get there, they also have files posted for firmware and for prints that will upgrade your printer just by printing the thing, you know, printing something that upgrades it, printing a different spool holder or a filament guide or whatever, or a fan duct. They kind of archive all those things together, and I don't know how they decided that Facebook is where they're going to do this, but most every printer at this price point and above has a pretty active Facebook group. So see if you can find the official one for your printer, and you'll probably get a lot of good information there. All right, we've done step 1, and it's about time to close down. I'll keep going until at least 9:15. That's when the class officially ends. I may keep going past that if I'm close to finishing, although it doesn't look like we're going to be close at 9:15. But I'll finish it up, and we'll come back on Monday and print something. All right, so it looks like now I'm putting the power supply in, and it gives you this picture in this diagram anyway. That's telling you to flip it to the 115 if it wasn't already there, and then we're going to mount the control panel. All right, so let's see. M5 8. No. It looks like these little guys, maybe. No, that's not 8. Here is the control panel. Get that. That's going to be held on with M420s. It's like these guys. And it's going to go on the front. Whoa, hold up. There we go. On the front. This cable is going to plug into it. I never remember which one of these expansion ports it plugs into. And it doesn't tell me. I'm going to go with 1, but if we don't get our screen working when we power it up, then you plug this cable into 2, and if that doesn't work, you plug it into 3. Nothing really bad happens by plugging it into the wrong one. And I don't remember which one's the right one. Let's see if I can find the right. This doesn't look like the right screw. It should be, but I don't see any others. I'd rather it have a button head on it instead of a socket head, but I don't see any button head screws. Oh wait, I got another bag. No, nothing in there. Huh. Well, we'll put these in here, but this just doesn't seem right. For one, they're kind of small compared to the hole they're going in. But we'll go with this for now, and no, we won't go with this for now. Oh, I read it backwards. It is these guys. All right, that does make more sense. This is the screw that's going to go here. All right. If I can get the hole to line up. And then this one, it's got a little protective coating on the screen. This is not a touch screen, at least not on the base level Ender. I think maybe the Pro does come with a touch screen. It's not particularly necessary. Again, I said we'll upgrade this. We will upgrade this one at some point throughout the quarter to a touch screen. Now's probably a good time to check what board we have in here. I wouldn't normally, that's not a thing you have to do to assemble the printer, but I want to know because at some point, one of the early things we'll do is we'll change out the firmware, or we'll at least look at the firmware if we don't change it. And to do that, I need to know what kind of board is in here. So let's look and see. Wow, that is tight. There we go. All right. So let's go down in there. Get a little closer and zoom. There we go. All right, so there's the number 4.2.2 board, right down there. Version 4.2.2, 4.2.2. So that will be important when we go to do anything with the firmware on the board. We need to know what kind of board we're working with, and so we got the version 4 board. Just so while we're here, and we can look at what's going on in here, these little black, oh wow, we're constantly going out of focus. There we go. These little black heat sinks, those are covering the drivers that are controlling the movement of all the stepper motors. And then these wires are connected one to each stepper motor. So there's 4 of them because I have 3 axes and the extruder itself, the thing that spits out the filament or that feeds the filament in. I've got a couple of fans over here. I've got my power rail that this bed is heated, so it will have power going to it and a thermistor that measures the temperature of it. And there's the hot end itself is heated, and those are they're just basically resistive heaters. And each one of those things that are heated, the hot end and the bed, also have a way to measure how hot they are, so they have a thermistor. And then I've got all these limit switches so that you can kind of hear it clicking. Well, here's one right here. Little switch that is going to tell when the printer has reached one of its limits. That's all how these printers know where they're at, is they have a limit switch where they measure, all right, once I hit that limit switch, I know where that point is. Everything else is dead reckoning from there. So the only feedback you get on these printers is the temperature. You don't get any kind of positional feedback. I might, I can't do it with this board, but I might somewhere in the quarter put some stepper motor on here that actually do give you feedback. Actually, it's an add-on to a stepper motor that gives you feedback, but only if I do that, it will only be just to show you that it can be done. But there's no feedback on anything. The printer just sends out signals, you know, move a stepper motor, heat a heater, something like that, without knowing what actually happened other than the temperature. The temperature is reported back of the bed and of the nozzle. But other than that, it's just guessing that, well, I told you to do this, I assume you did it. And so you can end up with prints that get way off track. Maybe you're trying to print too fast, and the printer can't keep up. It skips some steps, and it thinks it's in the right spot, but it doesn't know that it's not, and so it just keeps printing all over the place. So there are some limitations for this kind of printer, that there's no real feedback other than temperature. It doesn't even know that. There are some systems, this printer does not have it, but there are some systems that at least know that filament is in the system or not. There's some kind of new ones that know that filament is moving through the system, but most of the ones that have filament sensors just know that filament's there. It doesn't necessarily know that it's moving. But there are some that can kind of detect a jam. You know, the filament's it's there but not moving. But in general, there's very little feedback of what's actually going on in your printer. And so different ways that you can deal with that include remote monitoring. So at some point in the quarter, we'll go in and we will look at, oh, you can't see what I'm doing right now. Let's see. I'm just putting this guy on. We'll look at how you could, that's not going to work. I put the switch on the inside. We'll look at how you can have a webcam attached and maybe watch the printer on your phone. You don't have to be right there beside it all the time. There are even, it's called, what's it called? The spaghetti something. I don't remember. There's a plug-in for one of these remote monitoring systems that will go in and watch your print with artificial intelligence, and it can detect when your print has failed, and it can warn you that, hey, it looks like your print is not printing what we expected it to print. And it does it through a AI system connected to a webcam. So those sort of things, and we'll look at some of those. We'll add in some remote printing things to our to this printer. We'll need a couple of new things. We'll have to have a Raspberry Pi. If you want a camera, then you have to have a camera. Why are we not? This screw is acting like it's stripped out. There it goes. And so I do have all of those things that we'll be able to add. Just so you can see, again, you don't have to do any of those upgrades or changes. This little thing, just so I can point out, they've got all these little clips on the side. This is how a lot of these printers attach a removable bed. So I'm going to take all these off of here so you can see. This one may have a sticker on the bottom that can stick this bed down. I would not recommend doing that if it does. Let's see. I don't know if it does though. No, it doesn't. It's just this is kind of the same material that it's kind of a fiberglass material. So there's our aluminum bed, and this one has kind of a fiberglass type material with a print surface on it. Some of these are spring steel. This is not bad though. This will work pretty well. And so you just put it down, and then you use the clips, not on the side, but over on the edges somewhere to hold it in place. And then it's a little, annoying to have to undo all these clips. A lot of times I just use two. I just use these two a lot. Well, look at the thing. I just use these two a lot of times. This one kind of gets in the way. Sometimes the print head is going to go over here to home, and then it might draw a purge line right here or right here, and this one sometimes gets in the way. So a lot of times I don't use it if I don't need to, although it will let this corner lift up. But what we'll end up doing eventually is we'll put a magnetic bed on here so that we don't need these at all. It just sticks down, and then we can peel it off and pop our print off of there. All right, we have a few minutes before 9:15. We've got to plug in here. There should be a matching plug. You don't want to go over the rail here. You want to go under all of these cables. So we're going to go under, plug that in. There we go. And that will give power to the motherboard, and then to all the printer, the heat bed and the hot end and all that kind of stepper motors, everything. Here, the next thing it wants me to do is add this limit switch. So you're going to have a lot of these little cables to plug in. On the Ender 3 at least, they're all pre-routed, and it's pretty obvious where they plug in, and they can only plug in one direction. They're keyed to where they can only plug in one way. So this is going to go right here. And then this guy already has the screws. We do have just enough time to talk about these things. These are called T-nuts. And they're already tightened down, so I need to loosen them up, which I have misplaced my Allen wrench. Here it is. So you can see how these work. There. And there. So you loosen these to where they're just barely hanging on. And what they're going to do is this nut is going to slide into the slots here, and then it'll swing around and catch in this groove, and you'll be able to tighten up whatever it is you're attaching. You don't have to do this very often on this printer because it only has a few of these. Oh wait, but they're backwards. They put them in there backwards. So we got to take them totally out. Oh, no, it's going to go on the side. That's what it is. All right. Now, here's something that I'm going to do, and I don't know if you should do or not, but I'm going to do it. And this is probably only applies to the Ender 3. So if you have a different printer, this probably doesn't apply. But the printer comes with little nippers, and they put a stop, like this little peg right here sits against this rail and won't let this Z-axis or switch go any further down than right there. It bottoms out right there. And I want more adjustability. Remember, I want this bed to be as tight as possible. So it's going to be pretty low. And a lot of times that means that I have to chop this stop off of here. So I'm just going to take these and chop this little piece off so that now I can put this as far down as there if I wanted to. Now that's going to be way too low, but I'll have a little more adjustment. It doesn't really do anything other than I cut off this tiny, that tiny little piece off of this piece of plastic down here so that I could lower this a little bit lower, because it seems like every time I do this, I need it to be just a little lower. When you're tightening these things up, you just kind of spin them around, and those little T-nuts will, in this case, turn horizontal and grab in there. And I don't know where to start this at, so I'm just going to put it somewhere, and then we'll have to adjust it to get the, get it to trigger at the right height. But I don't know where the right height is right now. Let's see what they have us doing next. Next, they have us working right back here. So somewhere we should have a lone stepper motor, the one that the screw fell out of. I don't know where I put it. Oh, right here. So this is the Z-axis, so it's going to sit down here. Well, this is the Z-axis stepper motor, and it's also going to use those T-nuts to attach. Let's see if I can straighten this thing up better. And there should be a little bag that has them in there. Oh, no, they have, it's not T-nuts, they have a screw. That's good. So the M4 by 18. These little guys. No, that's 16. These guys with the countersink heads. What this one does is, and again, we're going to have to plug the stepper motor in. And so there should be some cables. Now these are labeled, so they have these little X, E for extruder. X, actually, I have two labeled X. Oh, that's the X end stop. So it's not those. Let's see what else I've got. Not those. Here it is. It's right here. So the Z, and again, they only plug one direction. So there we go. And we're going to do that and screw that thing in. Now, in some printers, I haven't had this as much on the Ender 3, but on the TiVo, if you have that one, the little, the tarantula, I've had to shim these things out because the rod that's going to mount into this coupler needs to be perfectly parallel to this rail here. If it's not parallel to this rail, then you're going to get your Z-axis is going to bind up on you. Everything's a different size. Some of these couplers have a little bit of a springiness to them. This one's more, it does have a little gap here. And I will talk about that in a second once I get this screw in. Maybe if I move this out of the way. So that gap, and some of them have several, almost like a spring in there. It lets this rod that's going to be in here, you know, kind of have some little extra movement to it, and that's good. Probably, I don't know if I have any of these right now. I might have to order them, but I'll probably replace this with just a solid coupler because I'd rather it not have any ability to move and just get it right the first time, you know, get it perfectly straight. There, I cut myself. Here's the rod. So it's got some kind of anti-rust, or maybe it's grease on it already. I don't know. I've never seen one with quite so much on it. So this rod, in order for these gaps to actually mean anything, you don't want this rod to go all the way down in there. And also don't trust that they've tightened this up. So this rod, and it is very much out of line right now. I'll show you from the side. I don't know if you can actually tell because you're looking at it, but you don't see how those are not parallel. You want them to be parallel as much as possible. And so you want to adjust. You may have to shim down here, or there are there is a little bit of adjustment in how this coupler sits also. Again, the ones that have more springiness in here will have kind of some built-in adjustment. Not sure what size these are. There we go. So I want to get it close, and then once we get more pieces on there, we'll be able to tell if we've got it actually aligned. Right now, it's just kind of, I can move it wherever I want it. I'm going to tighten up this bottom one also. It actually was already tight. Now see, that didn't actually grab. So let's try again. This is being difficult. All right, I think we're pretty well attached in there. All right, it is pretty close to 9:15, so if you have to go, that is fine. I'll go ahead and I'll finish assembling everything, just so we have it here in case you get stuck on one of these last few parts. Assembling it, there's maybe one-ish tricky part left. So I'll go ahead and finish out that. We're going to do our rails now. So we have a rail that goes across here and moves up and down. And then we have a rail across the top that holds everything hopefully square. Let's see if I can get these undone. These are different lengths, so it's a little easier to tell them apart. And not, well, I don't think you could put them in the wrong place. If you grab one and it doesn't look like it's going to holes line up, then you've grabbed the wrong one on this one. So the one that's shorter just has 2 holes in each end, and it's going to go across the top up there, but we won't use it yet. It's the last thing we're going to do. So this one, it has patterns of holes. Am I zoomed out? Nope. Yeah. All right. And so there are 3 that are closer to one end and 3 that are further from one end. So this one does matter which end I'm working on. I need my extruder. So they have already assembled extruder and the Y-axis motor and the Y-axis limit switch. All right, so this guy, let's turn our printer back around facing us. We're kind of at the back of it right now. All right, so this is the feeder where the filament's going to come in, it's going to sit back in the back. So it's going to, see these 3 wheels? They're going to go over this rail here, but we have to mount this guy to it. And this rail does have a front and a back. It's got these clearance holes to go around like this nut. So you definitely want to make sure there's nothing loose here, because it's kind of hard to get in there once it's all mounted. It looks like all of this is fine. I don't see any loose parts anywhere. So this is going to go in here. Come on. Oh, other end. Kind of like so. And we're going to screw into these holes, but from this side. So they've made these holes here for you to put the Allen wrench through, and so it's a little bit tricky to get all this assembled. We want those M416s, which I think are these guys. Yeah, these little guys. Had a little fall. Let's go ahead and find the correct Allen wrench, so I'm not trying to find that while I've got everything. All right, so that's the right one. So kind of have to do a couple of things at once. Come on, there's that one. There's that one. The clearance hole has to go over this nut, and we're going to do something like this. Can't tell if I'm lined up. There it goes. All right, let's get this one started, and then let's try to get this guy started. Once we get them both started, then it's just a matter of attaching them, so tightening them down. Always better to get all of the bolts and nuts, whatever, started and then tighten them all down, versus tightening one and then doing the next one. Now, another thing with this is you can't really adjust these without taking this whole thing apart off of this rail later on, because the rail is in the way. So you do need to go ahead and get these tight before you put this on here. Okay. Now, looks like that is set up. Now we need to put this guy. Now this is the hot end, so we'll look at the hot end itself in more detail later on, but this is where the filament's going to come out. This tube, the Bowden tube, is going to constrain the filament as it travels from our feeder to the actual melt zone over here. So this needs to mount on here, and by mount it just slides on. And so I've clearly gotten it too tight, so I need to back off on this eccentric nut until I can actually get this to slide on there. There we go. And that seems pretty free. It probably could be a little looser, so it slides a little freer, but it still doesn't wobble around, so that's good. All right. Now we want the other end, which is a bracket, this bracket. So this bracket's going to go on this side, and these wheels will ride on these rails. It's a little simpler to install than the other one. So we're just going to use our 2 screws here. Oh wait, they come from the back though. They come from this way. it has a clearance hole for the head of the bolt that's on this guy. Get this one. All right, again, this one you can actually tighten afterwards, but this one you can't without taking this all apart, which is annoying. Or at least taking it off of these two upright rails. All right, now we've got this assembly. Belt time. So it has this little timing belt. So it's a belt with teeth on it. And it's what's going to move the print head back and forth, and it's driven by this motor here. So we've got to route our belt under these wheels, around. Now I haven't put the end on yet, so there'll be an end. Well, it's kind of an end over here that we'll put on in a second, but we've got to go under the wheels, and it's usually easiest to just drive the wheels over the belt. At least that's what I found. And then pull the belt through. Okay. And then again, there's going to be a pulley. It's very unevenly balanced. Pulley over here that we haven't installed yet. And we want the teeth of this belt pointing in towards the rail here. And then how it attaches is there are these little slots, and it just slides in the slot there. This one is a little trickier because there is a geared pulley, or a tooth pulley, I guess, not a geared pulley, that it has to go around. And you can't have this belt twisted in any way. It has to, the teeth have to be pointing the right direction with no twist anywhere in the belt. All right, I think we've got that part. Now I'm going to have plenty of slack right now because I don't have this pulley on the other end that actually tensions it. That's another upgrade that we're going to... You can print this upgrade actually, but I do have one that is a store-bought one that allows us a little bit easier way to tension this belt. This belt is probably the one that's going to give you the most trouble in your early prints if you have kind of unevenness in the surface. It just doesn't look right. It's probably this belt is too loose. All right, there we go. And again, it's really loose right now because we haven't put the pulley on this end. There'll be one right here that we tension. In fact, that's what it wants me to do next. It's this little guy. So this guy is going to, it has more of those T-nuts. We got to loosen them up. And this one is tough to do with just one person because you have to hold a couple of things and pull and tighten all at one time, and so it's a little bit tough to do. But we will try. Okay, it's in there. Now, this is where you have to pull out on this, and it might be simpler to leverage something. I want to tighten some of these down a little bit. So we have a starting point, and maybe we can use this little screwdriver they gave us. I don't want to tear the belt or damage the pulley or anything, but we want to put a little bit, in fact, let's use something bigger. A little bit of tension on here to pull it out, and then tighten these down to hold it in place. In fact, let's tighten it this way. And if you don't get a good tension on this belt right here, like this is good. That kind of tension, that's good. Then if this belt is too wobbly, then this is gonna have too much slack in it, too much backlash. We're almost done. Now, this whole assembly has to go over both of these rails. It has to go over this rail and this rail while threading onto that Z screw that we put in. And so this part can be a little tricky. Except that it wasn't. It's very greasy though. I can barely turn the, wow. Do I have any kind of rag over here? No. They did a great job of greasing this Z-screw. I will say that. I gotta find something. I can't even grip it. All right, see if this will help. Oh, this is an important piece right here. So this is the strain relief on the wires that are carrying power to heat this bed and the thermistor. So you do want to check to make sure that you have something like that, because this bed's going to move back and forth all the time while you're printing. And if there's no strain relief, or if it's not working very well, then those wires will become loose. Whenever you're using wires for some sort of electrical, power, and they have a little bit of looseness to them, then they're not making as good of contact with wherever they're delivering that power, and that increases the resistance, which is going to create some extra heat, which can cause fires and bad things to happen. So you want to make sure that you've got a good strain relief. All right, somehow we got stuck. This is where I'm looking at, show you what I'm looking at. I'll try to show you what I'm looking at. So I'm looking at how this rod, is it parallel to this? And it's really, I don't think it is. What I'm going to do is I'm going to back these screws out a little bit, because it's way tighter than it should be to, oh, this is the wrong size, to turn this to the Z screw or Z stepper. I want to back these off a little bit, and I might shim this out and move it that way a little bit, because it's too tight. I can't see anything either. All right, so I'm going to give it a little bit of freedom here, and then we'll see where it wants to actually land, because I think it was just too tight. Yeah, it's way simpler to move now. So if you're doing this part of it, this is one of the parts where you might have to do some adjustment. I think I'm going to need to shim this thing out about close to 1/8 of an inch, maybe like, I don't know, 3/16 or something. Well, no, not 3/16. About the thickness of this wrench, actually. A little bit thinner than that wrench. So I'm going to have to find some shim. I won't do it right now, but it was just too tight to turn this. But I can't leave it, can't leave it loose like this either. So I need a shim between there. I bet if I look hard enough, there is a new mount that I can print for this. I'll probably just shim this out though a little bit, because it just needs a little bit of shim, and then this rod, the Z rod, is parallel to this axis. I'll finish assembling and see if anything changes, but it does kind of look like I'm going to need to do something to shim this. All right, these plug in. I've got the X limit switch, so that's going to be here. Got to reach up in there to plug it in. That's a little bit tricky. Okay, I've got the extruder E motor, stepper motor, and I've got hopefully an X stepper motor for this guy, and it goes on the bottom. All right. This tube, it needs a fitting to go into right here. And those fittings are right here. They actually give me 2 of them because they typically ship kind of cheap ones. And they also ship these little blue clips. These clips are for sliding on here. So the way you use these is pushing in on this collar should release the tube that's in here. They don't always work, particularly with the cheap ones, but that's the idea. So we're going to screw this over here, and we'll go ahead and take this collar out, or the clip out, put this in, and then put the collar on again. It looks like they did not ship. All right, so here's one. I'm going to try and remove it. We'll see. I'll push this down and then pull this out. So this one I want to pull out because it matters. A couple of things about this one. You'll save yourself some potential jams. This end needs to be cut perfectly perpendicular to this axis so that it can sit down in here flush. If it's at an angle, you know, this one, there might be a slight angle, but it's pretty minimal. If it's at a significant angle, this not being flush against the mating surface inside this hot end will let filament leak out and you'll end up with a jam. Also, if this is not inserted all the way down as far as it will go, you should feel a positive stop. You'll just create a gap that way and create jams. So I want to make sure that this is in as all the way. I don't think it was either. And then put the clip here so that it can't just work its way back out. The filament is going to come through this tube. This is called a Bowden tube, and that's what constrains it from, you know, just wandering all over the place, and actually forces it to come out this hot end. The only thing left is to put this guy on top, and hopefully it all lines up. It does have a top and bottom, so the little holes that are here are, that's on the top so that the bolt heads can go through there. And I do actually have one extra one. And so you come up with a couple of extra parts that go ahead and save those, because assuming that you get more and more printers and add-ons and upgrades and whatever, then these parts are pretty much interchangeable in, or at least the hardware, it's interchangeable in all of these printers. There we go. There, that lined up nice. If you have to do a lot, oh, I missed the thing entirely. If you have to do a lot to get these to screw together, you might not have it square. If it's not square, it's not going to move very freely. It won't be generally too big of a deal because you're not printing very tall parts most of the time. But if you try to use the entire axis here, the Z-axis, and it's not square, you're going to have trouble. So I'm just going in. This one actually has gone together pretty well. I'd say the only problem that I've had is that Z-axis stepper looking like I need to shim that out so that the Z-axis rod, the screw back here, is parallel to this rail. Otherwise, it seems like everything has been okay. We'll plug it in and see if it turns on. We won't worry with printing anything today because we've gone over by 20 minutes or whatever. All right. The other pieces are assembling the filament spool holder, which I don't know that I'm going to use that one just because I don't like it mounted on top of the thing. But it does save space if you do that. All right, plugging it in and hoping that nothing blows up. Fan came on the power supply, so that's good. This screen did not come on, but remember we were uncertain which one of these to plug it in. We plugged in one and that didn't do anything. Two didn't seem to do anything. 3. So it's the third one. So EXP3 is, I'll have to reboot it to hopefully get it to actually show something on the screen though. So let's see. There we go. So they've got a little title screen branded for the company that created the printer. One thing, everything should be fine, except you don't want to do too much before you adjust the height of this thing. So remember, I tightened my bed down as much as I could, pretty much. I don't think we really have time to do the whole bed leveling sequence. That probably needs to have more detail. But before you do any of your home, you just want to. Oh yeah, see, I'm gonna be way above, so it'll be okay. I'll run through the homing routine in the menu here. I don't know if you can see the menu. It looks like it's all kind of. Can I maybe reduce the exposure so you can see it? I don't know. It's just kind of washed out. But there's a prepare auto home. I probably shouldn't do, let's do move axis. And let's just move X and make sure that this guy moves. We'll do in 1 millimeter increments. Oh, yep. So that goes back and forth. Let's move Y, that's the bed. Yep, goes forwards, goes backwards. Let's move Z. So that should be up and down. Alright, so let's do the auto home. Now it won't necessarily home correctly because I haven't set this. Wow, we're way zoomed in. You couldn't see most of the movement, but they were happy. You could hear them, I guess. Auto home. All right, so what I would do at this point is I'd see the distance between the nozzle and this bed, and I would adjust the height of that Z-axis limit switch to get them close together, and then I would go through homing or leveling the bed, which is going to take 10 minutes or so. So I don't want to add that on to this one. Also, we'll do that on Monday. We'll start Monday leveling the bed and printing. All right. Hopefully your printers go together pretty well. It doesn't take terribly. We built this one in an hour, and talking through everything, doing a couple of things wrong, and then backing out and whatever. So hopefully yours will go together pretty well. Let me know in the Discord or send me an email if you have trouble that you're not sure about what to do. I would recommend joining the Facebook group for your printer, just because they do have a lot of pre-built files on Facebook in the files section, and there's a lot of people that will generally help. There's always people who won't, but I will see you guys on Monday, and we should be able to print something.